Okay, what you need to look at for today is to find a Maclaurin series using some elementary power functions that are already given. And so you're going to want to make sure that you have page 682, a copy of that table. And that table, if you look at it, has power series for elementary functions. It has 1 over x, 1 over 1 plus x, natural log, e to the x, sine, cosine, arctan, arcsine, and then the binomial power function, which we talked about yesterday. And this stuff that you're going to do, so basically we're going to be finding Maclaurin series from this. So what you're going to do, and I'm just going to use the example from the book. If you have the function f of x equals the cosine of the square root of x, what you can do is you can look and you can say, well, if I'm going to look for the power series for the cosine of square root of x, the Maclaurin power series, what I can do is I can compare it to the cosine of x. So if you look at the table, the cosine of x is 1 minus x squared over 2 factorial plus x squared, no, x to the fourth over 4 factorial minus x to the sixth over 6 factorial, and that goes on. And you can get that right from page 682. So if I want to find this function, the cosine of the square root of x, basically I just, instead of using x, in my power series, I take the square root of it. So it becomes 1 minus x over 2 factorial plus x squared over 4 factorial minus x to the third over 6 factorial, and that goes on. That's how easy it is. Sometimes when you substitute, so basically you're substituting the square root of x in for x. Sometimes the algebra is a little bit harder, but that's all you're doing. Let's try when you have to multiply two of them. Like say e to the x times the arctan of x. This one is a little bit harder when you have to multiply or divide. So if you're multiplying, what I do is I like to just write them down. So e to the x power series is 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial, and that goes on forever. The arctan, I'll put that one in pink. The arctan is x minus x cubed over 3 plus x to the fifth over 5, and that one then it would be minus, and that one goes on forever also. So usually when you're doing these, they will tell you how many terms you need because basically this is a big distribution property. You're going to distribute the x. You're going to distribute the minus x cubed over 3. So let's say, um, let's do the first 4 terms. We'll try to find the first 4 terms. So all I'm going to do is I'm going to distribute. If I take and I multiply all these together, and you can do this however you want, but just a lot more work. All right, so I'm going to take x times all these terms here. So when I do that, I get x plus x squared over 1. I'm not going to write that. Plus x cubed over 2 plus x to the fourth. That would actually be over 6 plus x to the fifth over 24. Now I'm going to do x cubed times all of these. So I'm going to distribute the x cubed term, and remember it's negative. So I get negative x cubed over 3 minus, this one would give me x to the fourth, so x to the fourth over 3 also. And then I would get, my next one would give me x to the fifth right here. And that's 2 times 3, so that would be over 6. And I'm going to stop there because I already have 4 terms. I said I think we were going to find the first 4 terms. So I'm going to stop there. Then if I add these together, right now I have x plus x squared minus x cubed over 6. That's just by subtracting those fractions. Minus x to the 4th over, what would that be? Actually, this one would be a plus. This one would be minus over the 6. And the x to the 5th term would be plus 3 over 40 x to the 5th. I asked for the first 4 terms, so really you could stop right here. So that's your first 4 terms. And that's how you do that. So it's basically easy. It's just a lot of fractions. And it's distributing. I could have went the other way and distributed the 1 and then the x. You'd get the same answer. All right, the other thing that you can do with these, besides multiplying, is you could have to divide. So let's say they want to know tangent. If you notice on page 682 on the table, there is no tangent. But you know that tangent is sine of x over cosine of x. And so you can use the sine of x function and the cosine of x function. And the sine of x function is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And that one goes on and on. And then cosine, we already did that one once, was 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And that one goes on and on and on. And so basically you're dividing 2 polynomials. That's all you're doing is dividing. So it's just a long division right there. So I would take my 1 minus, so I'm going to divide by cosine, so I'd have 1 minus x squared over, I'm going to write that as 2, plus x to the 4th over 24, and I'm going to divide that into x minus x cubed over 6 plus x to the 5th over 120. And let's say for fun that we only want the first 3 terms this time. I didn't tell you that, but let's say 3 terms because that's plenty for me. All right, so a little quick review on long division. All you do is you look at the first numbers here. So 1 goes into x, that would be x. So x times 1 gives me x. X times this term gives me negative x cubed over 2 plus x to the 5th over 24, and then you subtract this whole thing. And when you subtract this whole thing, so when I do that, I get that becomes a plus, so that would be a positive x cubed over 3. That one would become a minus, so minus x to the 5th over 30, if I just did that right. So I have 1 term, that's all I have so far. So then I need to do this again, get my next term, and my next term, because I have to put 1 in there, is just going to be whatever this leading term is here. So it'd be plus x cubed over 3. And then I distribute all that, so I get x cubed over 3 minus 1, what would that be, x to the 5th over 6. I'm going to stop there because all I need is 1 more. And so this next one will give me my last one. So when I do that, these cancel. This gives me 2x to the 5th over 15. And I'm not going to care about the rest because the last term that I need is going to be this term because 1 goes into that. You get 2x to the 5th over 15. And all I asked for was the first 3 terms. If I would ask for more, it'd take longer, but there you go. There's the first 3 terms. So that's what you're looking at today. Some of them are very easy, like this first one. I'm going to scroll back up, where all you have to do is replace x with something else. And then you have a couple problems where you have to distribute, multiply, and combine your terms. And then maybe one problem where you have to use long division. Okay, we will see you next Monday try to have everything done because we have a test that next Wednesday. I guess we won't see you next Monday, but the Monday after spring break. All right.